Hello, today we're going to be talking about lesson 4.3, which is on trigonometric functions on the unit circle. So, before we start about trigonometric functions on the unit circle, we have to talk about trigonometric functions of any angle. Now, if we look at our angle, our terminal side, right here, ends up making a triangle every time. So if you'll see right here, this is basically a triangle, where our x-coordinate is this length, and our y-coordinate is this length, and our radius is like the hypotenuse of a right triangle. So if you see right here, to figure out our radius r, it's going to be using the Pythagorean theorem to figure out that value. Okay, obviously your radius can't be 0, it's going to be some number. Okay, so we have these values right here where sine of theta is y over r, cosine of theta is x over r, and tangent is y over x. Obviously x can't be 0. Then there's cosecant, which is the inverse of sine. Instead of y over r for sine, it's going to be r over y. Secant is r over x, and cotangent is x over y. Obviously, y can't be 0. So let's look at an example of one right here. So we have the point 8, negative 6. So you can go ahead and draw your angle right here. And if you look right here, we have our x value, which is going to be 8 in our right triangle. Our y value is negative 6, because it goes down. And then our radius we have to find. So to find r, it's going to be equal to, we said it's equal to x squared plus y squared. So 8 squared is 64. Negative 6 squared is 36. Together that's the square root of 100. And you know the square root of 100 is 10. So our r is 10. So there's our triangle. So now we need to find the 6 exact values, which always means exact values means it's going to be a fraction, for the 6 trigonometric functions of theta. So let's look at sine of theta. Remember, sine of theta was y over r. Okay, so our y is negative 6, and our r is 10, which reduces to negative 3/5. Then we had cosine of theta, which was x over r. X would be 8 over 10, which reduces to positive 4/5. And then there was tangent of theta, which was y over x. So our y was negative 6, our x is 8, which reduces to negative 3/4. Okay? Now we have cosecant of theta, which was just the inverse of our sine. So that would be 10 over negative 6, which reduces to 5 over negative 3. Then we had our secant of theta, which was the inverse of cosine, 10 over 8, which reduces to 5/4. And then finally, cotangent of theta, instead of y over x, the inverse is x over y, which reduces to 8 over negative 6, which is negative 4/3. So you'll see the one thing that doesn't change is their signs. So the first one, our first one, sine, was a negative answer, so our cosecant was also negative. Our cosine was a positive 4/5, so our secant is a positive 5/4. That's the one thing that does not change. Now, we talked about y or x could not be 0 earlier when we talked about trigonometric functions. The reason that is because we get what's called a quadrant angle. And a quadrant angle is when our terminal side is on one of the axes. Okay, so right here, right here, right here, or down here at 270 degrees, or 3 pi over 2 radians. Okay, so these are our quadrant angles right here. All right? So let's look at this one right here. It says, find the exact value of each trigonometric function if defined. If not, write undefined. So my best advice is to always draw the picture. So if here's my coordinate plane, my negative 180 degree angle right here starts and goes to right here. So that's negative 180 degrees. So that would be the point, if you look at a coordinate plane, is going to be the point negative 1, 0. Okay, I'm over negative 1, I'm up 0. So that means that my x value is the negative 1, my y value is 0, and so my radius I can find by putting those numbers in. X squared, y squared. Square root of negative 1, or square root of negative 1 is 1, square root of 0, square root of 1, which is 1. So my r is also 1. Okay, so I know my x is negative 1, my y is 0, and my r is 1. So we need to find the sine of our theta. So remember, sine of theta is always y over r. So my y value is 0, my r is 1, which reduces to 0. Now let's look at tangent of 3 pi over 2. So I draw my circle. Okay? So I start here at 1, 0. I go up pi over 2, 2 pi over 2, which is just pi, 3 pi over 2. So this is the point right here, 0, negative 1. Okay? Find my r, that's my x, that's my y. R square root of 0 squared plus negative 1 squared. 1 equals 1. And you'll notice eventually that my r ends up being 1 every time. So you'll get used to that step. But for right now, we can do it out. So we end up getting r is equal to 1 as well. Now, we're asked to find the tangent of this 3 pi over 2. Okay? So remember, tangent of any number, of any theta, is y over x. So if I put my numbers in, my y is negative 1, my x is 0. Can we ever divide by 0? The answer is no, so this one is going to be undefined. Alright, finally the last one, secant of 2 pi, or 4 pi, excuse me. So I start here, I go pi, 2 pi, I go again, 3 pi, here's 4 pi. So where's my point right here? This is going to be the point 1, 0. X, y, I just told you that r is always going to be 1. So if I look at that one right there, I have to find secant. Secant of an angle is always r over x. So my r is 1, my x is 1. So my secant of 4 pi is going to be 1 as well. So the next thing we're going to talk about is called a reference angle. And reference angle is this angle that helps us figure out where our angle could be. It's generally the one closest to our axis. So if we look right here at quadrant 2, our reference angle is going to be from pi to this number. If we look at quadrant 3, our answer is from pi down to my angle. And if I look at quadrant 4, it's actually from 0 or 2 pi down from that angle. Okay? And so you'll see that there's all of these angles that you can find super easy. If sine of theta is b over r, that means that the sine of my reference angle is also b over r. The difference you'll see right here, cosine of theta is negative a over r, where the cosine of my reference angle is now positive because I'm coming from pi. Same thing with tangent. Instead of being negative b over a, the tangent of my reference angle is going to be just a positive b over a. You can look at quadrant 3 and quadrant 4, see the difference in their changes as well. So reference angle can be used to help find the value of our trigonometric ratios. So in quadrant 1, you'll see that our reference angle is just equal to our angle because it's coming from 0, okay? Piece of cake. Then, if our angle is in quadrant 2, our reference point is from pi. So you'll see it's right there. So the to find that, we take pi minus our angle, or if it's in degrees, 180 minus that angle. Quadrant 4, same thing. We're coming from pi, but we're going in the opposite direction. So what ends up happening is we actually have to take it and take the angle minus pi, or the angle minus 180, to figure out our reference angle. And finally, quadrant 4, our reference point again is from the x-axis. And so again, we take 360 minus that angle, or 2 pi minus that angle, to figure out our reference angle. So example 3 says to sketch our reference angle, sketch the angle, and then find its reference angle. So if I look at letter A, 300 degrees, right? Well, if I go around, this is 90, this is 180, this is 270, so 300 is going to be about right there, okay? So that's a 300 angle. So our reference angle actually is going to be this one right here, from the 0 point. So the way that we find that is we would take 360 minus my angle, which in this case would be 300. So 360 minus 300, my reference angle is 60 degrees. Let's look at letter B. Negative 2 pi over 3. Well, negative 2 pi over 3 okay, this is negative pi over 2, and then negative 2 pi over 3 is going to be like about right there. Okay, so notice it said in it that we couldn't use negative angles. So we need to figure out this positive angle the same way. So you try and figure out, to figure that out, what you're going to do is you're going to do 2 pi minus 2 pi over 3. Okay, so that's the same as 6 pi over 3 minus 2 pi over 3 would be 4 pi over 3. So that's what this angle is right here, 4 pi over 3. So my reference angle then ends up being this angle right here. We said it comes from pi. So what we have to do is we'd have to do 4 pi over 3 minus pi. So 4 pi over 3, and we subtract pi from it. So again, that's the same as 4 pi over 3 minus 3 pi over 3, and I end up getting pi over 3 is my reference angle. So that's right here, pi over 3. So evaluating the trigonometric function of any angle, okay, if I'm going to find that, I find the reference angle, which we just practiced. You find the value of the trigonometric function for that value, and then you use the quadrant to determine what it's going to be. So if we're finding the exact angle of this expression right here, cosine of 120 degrees,